Okay, this is the PRELAB video for the experiment to measure a magnetic field using the principle of magnetic induction. The premise behind this lab is that you have designed a device, a prototype of a device to measure a magnetic field. And the device consists of the following: a motor, a DC motor to cause this shaft to rotate. There's a shaft that can rotate. And wound on the shaft, and you might not be able to see it well in this video, is a coil. So there's many turns of thin wire that's wound around in this rectangular sort of shape. The two ends of that coil then go to a special device called a slip ring, and that's the device that's at this end of the apparatus. And the slip ring takes that electrical connection, which is going to be rotating, and translates it to a fixed electrical connection, which is on the back of this post, which we then are going to attach to the oscilloscope. So this is basically a fancy rotating electrical connection, so that when this spins, we're not sort of winding up a wire, we're still maintaining an electrical connection between the two ends of this coil and two pins which are on the back of this post over here. And that's it. That's the apparatus. This powered by a DC power supply, and this signal in the coil is monitored on the oscilloscope. And the way that we have the apparatus set up, student A will have their power supply being the power supply which drives the motor, and that's controlled through a VI, which you're going to use just to make sure you don't go too fast. And student B will be the one who's observing it on their oscilloscope. So you'll work in pairs on this experiment, and each of you will have some equipment that's running. So the principle is that as this coil spins, there can be a changing magnetic flux through the coil, particularly if there is a constant magnetic field in some direction and this coil spins. There'll be a changing flux through the coil, and that changing flux will induce an EMF in the coil, which is kind of just like a voltage, which we'll be able to monitor using the oscilloscope. And so if you think about it, if you had a magnetic field in the up-down direction, then you would have a large flux through the coil when the coil itself was horizontal. But when the coil went to be vertical, there'd be no flux through the coil. So you'd go from large flux to no flux, and large flux to no flux. And that is a changing flux, and that's what generates an EMF. But notice the way that we have this apparatus set up, that same effect, that same argument is true if you have a magnetic field from the side, from the horizontal direction. Because right now when the coil's like this, there's a large flux through the coil, and as the coil rotates, then there's no flux through the coil. And then the coil rotates more, then there's a large flux. And so whether there's a field in this direction or a field in this direction, it's going to cause an effect. Okay. The only direction in which we're not sensitive is the direction which is axial. A magnetic field in this direction never creates a flux through the coil because none of these field lines pass through the coil. Okay, so the idea is you're going to calibrate. First, what you're going to do is calibrate a DC voltage to angular speed, and DC voltage for the motor for angular speed of rotation. And how are you going to do that? You're going to, when this thing spins in the presence of a magnetic field, you'll get an induced EMF which will appear on the oscilloscope. So if I were just to turn on the rotation, and this thing's spinning reasonably fast right now, maybe I'll take this moment to make a note that this thing spins fast, although in the video you might not have seen it due to aliasing. It was spinning fast. So before you turn it on, you should make sure you tuck away any loose clothing or tie up your hair so your hair's not hanging over top, because you wouldn't want your hair to get caught on this and get wound up. So there are some safety concerns which are highlighted in the lab manual, and so please be aware of that. So when this thing spins in the presence of a magnetic field, even in the presence of the Earth's magnetic field, you can see we're generating a signal. For the purpose of this first exercise, we'll put a magnet actually in the magnet holder, and we'll get a really whoppingly large induced EMF signal. And it's this signal, the frequency of this signal is equal to the frequency of rotation of the shaft. And so now you know what voltage you've set for the power supply, and you can measure the frequency of rotation by measuring the frequency on the oscilloscope. Step 2 will be to try and do a precise measurement of the Earth's magnetic field, where you have this spinning at some known speed, and you will place the apparatus in the different orientations required as described in the lab manual to determine the magnetic field. And of course, the idea is you never have this thing, the apparatus spinning whenever you don't absolutely need it. So when you're thinking about things, or in between different spots where you're writing in your journal, you'll shut off the power to the motor so it's not spinning for no reason, just for safety reasons. A large part of the beginning of this experiment is your predictions. So before you even get started, you're guided through a series of you're guided with a series of questions to think your way through what this experiment is actually doing, or what is the magnitude of the signal you might actually expect to see. And so that's a large part. I think you're expected to spend about 45 minutes on that section. So please don't skip quickly through it. That's where really all the understanding of magnetic induction is going to come in. So I'm hoping that through that exercise you'll get a real deep understanding of magnetic induction. If anything was unclear about induction before you came to this lab, hopefully that will clarify things. So that's an important section. The output of the result of this exercise is, please read the post-lab exercise carefully. You're not going to write a typical lab report. You're going to make a product spec sheet for this device, and that will be your report in place of your report. So please don't submit a standard looking report. There's a sort of one-page specification sheet that you need to submit on your prototype device, or your device that you want to market. Okay, good luck. I hope you have fun on this one. I think it's going to be a lot of fun, and we think it'll be really instructive for you.